Hello everyone, my name is Matti Tahvonen. I work as a developer advocate here at Vaadin, and I'm honored to host a webinar on alternative JVM languages. As you probably know, Java is first compiled to bytecode, and this bytecode is actually then executed by JVM, and this combination of JVM and bytecode is actually the thing that actually makes Java platform independent, so that you can execute it on any kind of machines, from supercomputers to just some very small Linux machines, or even on Raspberry Pis or something. And it's also very highly optimized, and it actually has nothing that is tied to the Java language itself. So that's why it's a pretty good basis for executing other languages as well. There are different kind of existing languages that has been made to work, or made so that they are compiled to bytecode and then executed on JVM, like Ruby. You can take your Ruby on Rails application and just run it on JVM using JRuby. And there is same kind of things for Python, Ada, Pascal. And then there are lots of languages also which are actually kind of born on JVM, so that the JVM has been the original execution platform for these kind of languages. And these are actually the languages that we are going to be handling today. And from those languages, Clojure, Groovy, and Scala. And this topic itself will be quite interesting to me as well, because I haven't actually used any of these languages in any real application at all. I have been prototyping with some example projects, and I have followed this subject so that I've been taking part in some conference talks and such, but I have really no experience on any of these, and that kind of makes me also non-biased to host this kind of session where I will be interviewing 3 different language users, and the first one will be Matti Vesa, and hello. Matti will be talking about Clojure.
Yes.
So I know that much of Clojure, that it's a Lisp language, and my experience from Lisp is configuring Emacs, and I didn't succeed in that, at least not that well.
Yeah. So you're a current Vim user.
Yes.
So yes, Clojure is, as you said, it's a Lisp, and it's specifically made for the JVM. So there are other Lisps for the JVM. There's ARM-Pair Common Lisp, and there's Kava, for example, for Common Lisp, and Kava is for Shim. So one of the main points of Clojure is that it handles state, or manages state. So unlike in Java, where everything is mutable, in Clojure it's a very central point that data structures and variables are by default immutable. So when you pass a collection to a function, and you get the value back, the original collection isn't changed. So the modified collection is returned, of course.
Yeah, the syntax of Lisp-based languages is very different. Like if you compare if you have sometimes done something in C, you can pretty much read Java code and C++, but for me, I pretty much have experience only from C-based languages, like Java and C. So that's why it's very, very different mindset. So
yeah, it's very foreign to look at.
Yeah. Do you have some kind of Lisp code so we can see that?
Yeah, here
lots of those parentheses and.
Yes. So here's a simple example of Clojure code. So as you can see, everything begins with a parenthesis or parens, and these are basically function calls.
Yeah.
And the structure is very uniform, so it's
something that I can recognize here is the import clauses, but that's pretty much it. So you can import existing Java packages like Vaadin UI packages and use those in Clojure.
Yeah, and as you can see from the import expression here, it's a bit more flexible than in Java. So you can import a package, and from that package you can just list out the classes you want.
Yeah, so you don't need to repeat this com Vaadin add-on DutchKit UI part, which I pretty much repeat in every Java.
Yeah.
Or I don't repeat it. The IDE repeats it, but it's still,
and that's one point also with Clojure, that it's very compact and very expressive, so you don't necessarily even need an IDE to edit the code.
Yeah, and it's pretty quick to see kind of an overview that okay, it's these classes which are from that package, and then the basic packages, basic components from button and text fill and CSS layout from the Vaadin UI package.
Yeah, and the code is Clojure is dynamically typed. So that's something that contributes towards the code being smaller or more compact.
Yeah.
Because you don't have any type declarations, and some people think that because it isn't statically typed, for that reason, then it's not as safe as other languages. But I don't know about that.
Yeah, but they are making pretty large applications with JavaScript as well.
And that's true. And Clojure does support some typing.
Yeah.
And so you can declare.
So there's an optional typing.
Yes.
Yeah.
Optional typing.
Yeah.
So and of course interoperation with JVM or Java code is very good, called java.notation. You can see here, for example, in here we have the construct view function.
Yeah.
We have this let block here, which declares variables. These are local variables.
Yeah.
And here, for example, the view variable, after it comes an expression navigation view dot. So this creates a new navigation view class.
Yeah.
And here below, there's the do to expression. This does to the given object, which is a view here, which is a navigation view, it calls the following methods.
Yeah, so again, we don't need to repeat this view name there, which we would do in Java, plain Java code.
And this is one of the points I like when working with Clojure, with Vaadin, because you can omit so much. So I could write here view set, caption view set, content, and so on. But I can do this, and it's much more compact. And when you're writing a lot of Java code or Vaadin interfaces, then you can have lots of lines of declarations of your interface. And with this, I think it's almost declarative. When you look at it, you have caption this, content is this, and so on.
Yeah, so it's like a declarative expression. You don't need to still do any XML.
Yeah, and so basically you get declarative UI interface declarations with Clojure without any extras.
Yeah, and this is done with plain Clojure syntax, so there is no extra Vaadin library.
No, this is just
on some of these JVM languages. There are some helper libraries that active users have done, and that makes it kind of easier to use Vaadin's Java APIs with those languages. But with Clojure, you don't pretty much need it.
Yeah, I don't think so. That there is one library, I don't remember the name at this point, but there aren't any complete support libraries for Vaadin.
Yeah, but it makes some APIs more adapted for Clojure still.
Yes.
Yeah.
So while I'm using Eclipse here, there's also build tools for Clojure. Leiningen is probably the most popular. And with Leiningen you can create Vaadin projects also very easily. So
yeah. This seems to be pretty much the trend that each JVM language, they always need to make their own build tools. So for Scala there is SBT, and for Groovy there is Cradle.
Yes. And also many of these build tools, they also use the same package repositories, for example, or actually they always use the Maven central repository. And Clojure has its own Clojars repository. And you can of course use the add-on repository that Vaadin has.
Yeah. How is it, can you mix Java in the same project, or?
Well, of course you can. So you just use the Java.interoperation to access your Java classes.
So you can compile both Java classes and Clojure classes, and then use those in the same Vaadin application.
Yes, and you can use Java code in some points for performance, because the immutable data structures are really good.
Yeah,
and they are
safe to use.
They are safe, yes, and since they are immutable, they are very functional, very good to use in functional programming. On the other hand, they are slower, so Clojure has this feature called transients that allows you to make temporarily make a immutable collection become mutable and use it in the same way you use it if it was immutable, but it will be faster.
Yeah. So in theory, you can like package all the heavyweight stuff in some AGP and then use that AGP in your Clojure UI class and
for example,
make only the UI with Clojure and do the business logic still in the plain old Java that you have lots of experience.
You can just write the application using Clojure first and then profile the slow points and then transfer them to Java.
Okay. How can you kickstart this?
It's actually already started. So
okay, I want to see it.
This is the same application from the book, so nothing too complicated. But you can see the correspondence to the code and the UI. For example, here is the list, planet found probed, and here you can see this do-seek expression that constructs the list. So it's, I think, pretty readable, easy to find, that where it's built in the code.
Yeah, and this example was using TouchKit. And
yes, and this is since you can use lining and compile Clojure modules into classes.
Okay, so this is only one view from your application which is built with.
No, this is actually this is a small application just from the Vaadin book or book of Vaadin.
But there is a Java version of this.
This is actually this is Clojure code that's called from Java. So here we have the LT class. And what this does, it gets from the ClojTouch namespace the main def or var, and it invokes it using the UI that's created here. So basically, this is the easiest way to get into Clojure from a Java project.
Yeah.
Since the Clojure is actually just a approximately 3.5 megabyte jar you can drop into your project, and then you can do this. That's done here to.
Yeah. So this kind of the compilation of Clojure code is done dynamically.
In this case,
during the execution.
Yes, and it can be done ahead of time.
Yeah.
This is maybe better for when you're developing, because you can just refresh the file and restart your application instead of having to compile it all the time.
Yeah. Yeah, and you don't need to install the JRepo to do that.
Yeah, in this case you don't need JRepo at all.
Yeah. Replace the old classes. Yeah. Okay. Now I know much more about Lisp. I think maybe I can configure my Emacs next time better. And next we will have John Ahlroos here, who will be discussing about Groovy. Jon, get up here.
Hello.
Alright, let's connect your computer so that we can see your examples. Okay, so Groovy. Groovy is, I know a bit more about Groovy than Clojure. I've actually used Groovy sometimes. I've used in a build tool because they're in Gradle builds, the actual configuration is Groovy code. And then I have actually checked out one project and tried it locally, which was some kind of Groovy on Rails application, and that looked quite interesting actually to me, and I like this kind of full stack applications that have everything thinked out of the box, so that I don't need to implement. I only need to implement only my actual business logic and don't need to think about any persistency and how should I do this and that. So that's a kind of a complete stack. But let's first talk about the Groovy itself. That's the real thing here. So
what is Groovy?
Yes.
Groovy is very close to Java. It tries to live with Java quite a lot. If you're a Java developer, you're going to find Groovy very familiar. In a while, I'm going to show you an application where I basically take a Java application, add Groovy to it, and show you how to use Groovy within a Java application. Groovy itself is a dynamically typed language. It uses... but we could actually go into the application.
Yeah.
It's much easier to explain that way.
Show me the code.
Show you the code, yes. So I here have my IntelliJ app up and running.
Yeah.
In it I have my demo application, which basically is this kind of simple CRM application.
Yeah, this is actually very familiar for me because I built this a couple of months ago.
Yes, you should suggested it to me. So I thought we would basically take this view and implement it in Groovy fast. I will only implement the table and the filtering, and we're going to leave all other things as exercises. But so this is now a total Java application. It's built on Maven, and it has the usual buzzwords like dependency injection, CDI, and all other things. AGB, yes. JPA, you know all those. Yeah. So I'm going to take this.
So it's a standard Java EE application, pretty standard, except Vaadin actually. And Vaadin is used there as a UI, and now we will use Groovy to implement one of the views.
We're going to make one of the views. So the first thing you need to do when you take this kind of Java application is to add the Groovy dependency, of course.
Yeah. Yep. So this is pretty much same as in Clojure. So you need one dependency.
You need this one dependency, and then you're
that's
done.
It. Yeah.
One point though, if you're compiling this outside of IntelliJ, you will need to configure the Maven compiler plugin to use the Groovy compiler.
Yeah.
IntelliJ is so smart here that it will automatically use the Groovy compiler once we add it to the class path here. But yes, let's take...
But you probably want to do it because you will compile your application also in some CI server or something.
Yes. But I'm going to skip that step because we are using IntelliJ here.
Yeah, and most often Groovy users will use Gradle for compiling.
They will absolutely use Gradle because, yes. Anyway, what you do next is just add a new directory here. Source directory, I mean.
Yeah.
Call it Groovy. It's basically the standard for Maven projects.
Yeah, Maven gonna mention that you have different kind of languages in different directories.
Yeah.
Yes.
Then let's just take this about view and use it as a base for our application. Just call it. We already have one customer list view, so I'm gonna name it a bit differently, and then let's just put it there. Groovy source files end with Groovy, so we need to rename it.
Yes.
The first thing you notice here is that we have no red.
Yeah, it compiles already.
Yes, it will already compile to Groovy.
Can you open the source code so that to the full screen?
To the full screen?
Yeah. Just double click there. Yes.
Like so. Okay.
And now increase the font size a bit.
Yes.
Perfect.
Good. Okay, so now we have the sources here. Let's remove this, which we won't need. So this is basically one view in the application.
Yeah.
This is what you start with.
And you can use all the CDI injection points there.
Yes. Groovy fully supports using all Java libraries you can find, so you won't miss anything.
Okay.
Okay, we have this far. Should we see if this runs? Oh, run, of course. So I'm just now redeploying the application to the application server.
Alright, there we go.
Refresh, and we have the new customer list view here.
Yes.
It's still empty, but we'll get to that. Next off, let's implement something to just show off how the Groovy syntax looks like.
Yeah, this is pretty much Java to me.
This looks very much Java to you, yes. So let's improve this a bit.
Yeah.
First off, Groovy doesn't need these kind of semicolons.
Yeah.
It doesn't really use them. So we can just select all and remove the semicolons.
Yeah.
Then let's start. The first thing I'm going to show you is how to create a simple label, Vaadin label. We can do it like this. And this will create a label for us. It's the header label.
Yeah, and no typing.
No typing here. Groovy will figure it out at the runtime.
Yeah.
Let's add it to the view. One other thing you might want to look into is, let's set the style name for this. So what you see here is I'm using this kind of property.
Yeah.
To a Vaadin developer or Java developer, this looks like I'm accessing the field, right?
Yeah.
But what Groovy actually does, it uses the setter
function
for the style name.
Yeah.
Similarly, if you are getting a property, it will use the getter.
Yeah, this is probably one of the most discussed features that everybody are wishing for Java. So
yes,
so
and it's very
automatically
convenient.
created getters and setters.
It's there. So if you create a new class,
it's pretty much the same thing here.
Yes,
that they are wishing for Java.
They are. Many say that Groovy is Java on steroids. So.
Yeah.
Anyway, let's continue. We probably want our customers in the table we had previously here. So let's just use the service which is injected here. Oh, sorry. Yeah. Let's put that here. And we wanted a table, so we can just say like this.
Yeah.
And we get our table.
Yeah.
Let's add that.
So this as is pretty much constructor parameters.
Yes, basically, yes.
So use these as a constructor parameters.
Yeah.
Yes.
Here I used the list as a label.
Yeah.
And then here I just took the customers list and give it to the M table.
Yeah.
Okay, let's just quickly have a look at again what it looks like. Okay, now we have our table here, but there's a lot of stuff here we didn't previously have.
Yeah.
We should probably remove some columns here. So I'm going to show you a very quick way to do that. Let's configure the table columns. It's really easy. You can just do, we want the first name column, call it first name. We want the last name.
Is this some kind of map?
This is a map, yes.
Yeah,
this is how you define a map in Groovy.
Yeah.
We had status there still. And let's just create a variable of that. Call that columns. Oh, sorry. And then we can just tell the table to configure. And also the headers, of course. There you go. Now there we have the correct columns.
Yeah. At least IntelliJ seems to be quite well.
IntelliJ has excellent Groovy support.
Yeah. Do you know about other IDEs have you used?
Yes, I use Eclipse quite often.
Yeah.
And it doesn't come with Groovy support.
Yeah.
But
there is a
plugin for it.
Like so for everything in Eclipse.
Yes.
Yeah.
I've used those both, and both are great.
Have you tried NetBeans? Is there some kind of?
I haven't actually tried NetBeans.
Yeah, I haven't either used Groovy in NetBeans, so I have no idea either.
Yeah, that would be interesting to look into. Anyway, now we have our table, now we have our customers. Let's have a look. We are missing one thing.
Selection.
I'm not going to go into selection. Okay. I was thinking about filtering.
Okay.
Because we had this filter field up there.
Yeah.
So
Also, there we will show some event listeners, so that's a good example.
Yes, I thought I would show you how to do that. So just let's create a text field this time like this.
So you can still use the new syntax because it's Java.
Yes, but Groovy also has enhanced this a bit. So let's say we want to set the input prompt here.
Yeah.
So, or the width. And these are not constructor parameters.
Okay, but these are executed afterwards.
Yes, after construction, these are setters on the object. So let's just do this, add it.
But it kind of looks like a constructor.
Yes,
so.
you can basically construct the object.
Pretty much help library developers at least, because they don't need to make so many constructors.
Yes, you only need to make one.
Yeah.
And then you can use those. Okay, we have the field, we have the table, we have the header. We still need to configure the filtering stuff.
Yeah.
Groovy has these kinds of Java developers will know them as lambdas.
Yeah.
In Groovy we call them closures.
Yeah.
Not closures, closures. And they are pretty similar. So we can basically create here a filter and sort customers closure. And closures are defined like this.
Okay.
Let's pass in the customers and let's pass in a filter with a default of nothing. We want to filter probably by first and last name here. So I'm going to create a regexp of this filter so it's easier to match against the first and last name. It's pretty easy. Groovy provides pretty nice way of doing this. So that's now a regexp. And now let's just pick the customers which has the first name or the last name matches the regexp. Look at that.
Yeah, it looks simple, but I didn't read that anymore.
Okay, so we just search the customers, all customers which have the first name matches this regexp and the last name matches this regexp. And this regexp is basically contains...
Is the IT there? Is it like...
It means basically the current customer.
Yeah.
So if you
like
want to name it, you can say like this
and
then...
Iterated is the
yes,
instance. Yeah.
Yes.
So it's a convention.
It's a convention thing, yes. And then we wanted to sort them, and let's use the last name. Sort by last name. Now that we have this, we probably want to first filter and sort the initial set. And then we want to use the text field whenever a user types in the text field and trigger this filtering and sorting again. So we can just add to the text field a text change listener. Again, we use a closure instead of a listener. And then we just simply like that.
Yeah.
Now we should have the view ready. Let's take a look at it.
It's a bit bad habit, but it explains quite nicely the Groovy syntax, because now you're not doing the search in the database.
No, I'm not.
But you are doing so you are selecting all from the database and then sort the in-memory list and then pass that to the base.
Yes. You can of course optimize it by doing it in the database instead.
Yeah. You could just simply call the service call. But that's
but
not the
I
point
wanted
here.
just to show here.
Yeah. Perfect example for Groovy.
So now that we refresh, we noticed that it's sorted by last name, and we can basically filter it here.
Okay.
Let's have a look still. This class looks a bit Java-ish, I think. I mean, as you see here, we have these empty methods here.
Yeah.
They are really a pain because we need these because we need to implement the view.
Yeah.
Groovy allows us to fix this using so-called traits. Are you familiar with traits in other languages?
Yeah, I pretty much know them.
Yes. Yeah. So what a trait is actually an interface with the default implementation.
Yeah.
So what we here can do is just, instead of implementing a view, implementing a trait. And let's just put it in another folder. Select the Groovy source and put it there. And our trait instead can implement the view. And then we can just...
Yeah, and now it kind of takes the default method from here.
Yes.
Yes.
And all our views don't need to have this extra craft here.
Yeah.
And that's one way to use a trait. Groovy also has another way. It uses you can use traits in two ways. And this is pretty cool. Have you ever tried to combine two columns in a table into one? Let's say you want to combine the first name and last name. What usually do you do?
If I'm using Vaadin table, then I'm using column generator, and then I'll just replace those first name and last name columns with the generated column, and that just concatenates those.
Yes.
Yes.
We can do in Groovy without actually touching the table.
Okay.
Using traits here. Runtime traits to be more exactly.
Okay, so you can also kind of do that for the
beans.
entity itself.
Yes, the entity is itself.
Yeah.
So let's modify our nice closure here and add one thing here. Collect all will allow me to do transformations on the entities or beans themselves. So what we here can do is say just it and with traits. Now we need a trait which says that this has a name, not just first name, last name, but a name field. So let's create a name trait here. Again, just quickly adding it there. And our name trait will just have a name with a first name and a last name, like so.
Okay.
And then simply, now if we, maybe we want to just remove this.
Yeah, that will probably not work.
Yeah, so like this. And now if we just run it, we will get a nice name column there instead. And we didn't even need to touch the table here, so the table is still intact.
So we just created kind of a offline modified version of the entity, and then the entity has this generated column.
Yeah. Oh, it didn't refresh for some reason.
Okay.
Anyway.
Yeah, I can believe you.
You believe me?
Yeah, just use JRebel and then it would work. Does JRebel work with?
It works. Yeah, it works
Groovy
fine. Yes, it also
okay.
works.
Groovy has also quite many libraries. It has this Groovy and Rails.
Yes.
Yeah. So that's pretty much like a replacement for the Java EE stack, but totally written, or not totally written with Groovy, but it has like a...
It actually uses elements from the...
Like JPA at least.
Yes, JPA, and it uses also Spring Security for security.
Yeah.
And other things. We can
so they haven't implemented everything by themselves, but
no.
Made a kind of a Groovy-like framework for...
Basically, what you saw here was
applications.
Yeah. Basically, what you saw here was I took one application which was pre-configured and added Groovy to it. If you start from scratch, you might not want to add all those layers to the Java EE stack. So, what Grails basically does it provides you with a pre-setup of the whole stack.
Yeah.
And it does scaffolding and things like this, so you don't have to write all that.
Yeah.
yourself.
Yeah, you definitely need to check out that. We can add a link to the forum afterwards about Grails.
Yes, I can show you. Grails has these really nice pages where you can read about it more. Also, one of our community members.
Yeah, there is also an awesome Vaadin.
Yes,
I don't know. That's exactly what I have been watching beforehand.
Yeah, he has written this book where he actually uses Grails and Vaadin together and shows how you can use it. It's very informative.
Yeah,
and you can buy it online from his site over here. We can probably paste these links.
Yeah, we will add these links to the forum after the webinar, and we will also add all the example codes. So
of course,
you can probably add the fork version of this example application, and Matti can add those. Or actually, that your example was already in GitHub, but we can just paste that link to there as well after the webinar. Okay. I think we will run out of time if you don't move to the Scala, because I already saw that Henri Muurimaa had quite a lot of notes made for the Scala as well. So,
thank you very much.
Yeah, thank you.
Hi.
Hi.
How's it going?
We are going slowly.
Alrighty.
It's already 30 minutes, more than 30 minutes done. So let's try to make it quick. I know you have lots of things to say about Scala. I know you are very enthusiastic about it.
Yeah, Scala is great.
You might actually have seen Henri's talks on some conferences, and you are most often emphasizing not that much Scala, but also think that Scala kind of has born for reactive programming and functional programming.
Yeah, I think that Scala itself is a really good combination of functional and also object-oriented code.
Yeah, and especially when Java didn't have any support at all for
yes, this was of course
or very limited support for
before Java 8, but still the functional support in Java 8 is actually not so great. It's okay, but there are still several drawbacks, and I think Scala fixes them really well.
Yeah. Okay. Let's check out some Scala.
All right, so I have here an Eclipse project. I'm using Eclipse since TypeSafe, the company behind Scala, is actually providing a really good Scala ID plugin for Eclipse.
Yeah.
So this is just basically a Eclipse project. And one feature of this plugin is that they have something called Scala Worksheet, which is basically an interactive interpreter for Scala code. So let's create one right now. So,
have you used Scala in other IDEs, or are you just Eclipse user? Because the one time that I have been using Scala code, I've been using IntelliJ and NetBeans, because I didn't make the Scala ID actually work, but apparently it's now much better than it used to be.
There are many people using IDEA at least, and NetBeans as well, but for some reason I haven't put in the time to actually learn those. So I'm using Eclipse. It might not be the best, but it's good enough for me. So. All right, so here we have the worksheet. Let's make it a bit bigger. So basically this will evaluate all lines I'll write here immediately, and also print the result of that evaluation on the comment on the line. So here we can see that it's evaluating the print line here.
Okay, so this one is the actual evaluation result, this comment line.
Exactly.
Yeah.
So let's remove that and let's create a number.
Yeah.
And let's say it's number 5. So I'm going to save that, and it's going to tell me that I will create a value, number of type int, value is 5.
So no need to launch the application and check it with your debugger that what's the value here.
Well, this is a feature of the worksheet plugin for the IDE, so or you can use the REPL, that is a command line interpreter for Scala code as well.
Yeah.
But anyway, Scala Syntax has been built from ground up. It's not improved Java like Groovy is. So Java code will not compile with Java compiler or vice versa.
But you can still mix Java and Scala code.
Yes, on a bytecode level.
Yeah.
So actually the libraries have a really good interop. You can use Java objects on Scala and Scala objects from Java.
Yeah. that's a very good feature in all these JVM languages that they can also, if somebody writes a good library in one JVM language, you can still use it in other languages as well.
Yeah, that's right. All right, but a brief tour about the Scala syntax. So one thing that people will immediately notice that I didn't declare any type for my number variable or value actually. And this is because Scala has a really good type inference, which means that the compiler will look at the values or the expressions that I'm trying to put into the number value and deduce the type. And in this case, of course, we can see that 5 is an integer, and so the type of my variable or value is int.
Yes. So it's strongly typed, not loosely typed.
Extremely strongly typed, and actually working with the type system is really a big part with Scala and can get you done really amazing stuff.
Yeah.
And another thing here is that Scala emphasizes some immutability, and this means that
in the same way as Clojure.
Yes, and this means that if you create a value, you shouldn't be able to change that. So we can try to change that number here, and the compiler will complain that reassignment to val. Not everything is immutable, of course, so we can create a variable with the var keyword. Let's go 10 and typo. That one. And now we can actually save it, and we can see that we created the new variable there, and also assignment is fine. Second interesting thing about Scala is that almost everything is an expression instead of just a statement. And one example of this is the if expression. So actually, if I do an if clause, it will produce a value like this. So let's first create a Boolean value here and try to do something with that. If that value does something, let's say I'm returning 10 here and 5 otherwise. And we can see that the interpreter actually evaluated this and found out that the value of this expression is 10. Well, of course it is. And we can also store that in a value.
So now you don't need to, like in Java, you would need to present the variable beforehand and then assign it there inside the if-else clause.
Yes, because this is actually evaluated on runtime.
Yes.
Also, I can, if there's a block that has only one statement in it, I don't actually need those curly braces here. So I can remove those and actually make this whole thing a one-liner, which is quite nice for simple stuff. This is the same thing that Java has with the question mark and colon syntax. That doesn't actually exist in Scala. So let's look at how functions are defined. So actually, Groovy are using def for variables, but Scala is using that for functions. So let's define a new function. And we need a parameter here, so if it's a big number or not. And the result type is int, and the value of this function is, let's say, this if clause or if expression here, of course, let's rename that.
Yeah, so in function declarations there you must declare the return type.
Actually, no, I don't. I can remove this because compiler is smart enough to figure out.
Yeah, so now it can dig into the actual function and find it there.
Yeah. And actually it's pretty smart. I can have a really long and complicated function, and it will still be able to, in most cases at least, to figure it out. Yeah. One thing where this doesn't work is that I'm using recursion, because then it needs to understand the return type to find out the return type.
Yeah.
So then I need to declare it.
So in simple cases you can just...
In most cases, actually. Yeah. So, and also, since this is only one block, I can make this a one-liner as well. When I call this tree, we can see that, yeah, sure, I'm returning the 10 here. But I can also use the Scala support for default values for parameters. So let's say we want to have a default false here.
No, by default it would be.
Yes, okay. And now we can just remove the variable here.
And it still returns to yes.
Yes, and also interesting and really useful is that I can use named parameters here. So I can, if there are lots of different parameters here, so let's say we have a string and other parameters here with default values. Let's say that's 10. I'm not using them for anything, but if I want to just specify some parameter here, I can do it so that I will actually, when I'm calling the function, give the name there and specify, in this case, what I want. This is
that's actually a very good thing in Java, because in Java there is often lots of big methods and there are lots of toggles often in those methods, and you have no idea what this true means.
Yeah.
So this kind of makes it easier to
and also in the implementation
document it also in the source code so that you can see it there.
Yeah, combined with the default values, actually, you can get rid of the pattern when you actually create lots of different variations of the same method with just different set of parameters.
And you probably, I have no idea, but you probably don't need to have them in right order either.
No, of course. Yeah. Of course, they can be in any order if you are naming them on the calling side. Looking at classes next, so classes are defined a bit in Java, so with the class keyword, and I can give a class a parameter, and actually this will be a field for the class. So, and also can
it's
give
pretty much a field declaration, but it's there.
Yes.
Yeah.
And this is actually a valid class declaration. This is, I have now declared one class that has one field, a number or num, and it has a default value. So I can just go ahead and construct that. So.
And does it have a similar default methods like in Groovy?
You mean traits?
Yeah.
Yes, actually, Scala has a really powerful trait system as well, which is quite a bit similar with, I understand, Groovy has.
Yeah, but so, yeah, okay.
And interesting thing here is that when I'm defining class, the body or the expression in the body of the class is actually the constructor code. So I don't actually have to create many different constructors usually, because I can just really flexibly give all the parameters here with the default values and the names and just use them once in the body. So let's say I want to print something, print the number here, for example. So now actually when we see it's actually printing the number here. Let's put a print line and it's on line what you can see here. And here I'm using the Scala string interpolation capabilities to actually use the flexible way of building strings, which is quite nice.
Yeah.
All right, so basically that's most about the what I have to say today.
That's what it looks like.
Yes.
So, but how do you use it? Do you normally use some special libraries when using?
Well,
Scala?
I'm using Vaadin, for example.
Yeah, so you can use pretty much any Java libraries.
Yeah.
But with Vaadin there, you have this Scala thing. That's kind of an extension to Vaadin.
Yes, I'm going to introduce that in a minute, but one thing actually regarding classes. Scala has something called case class, which is a special type of class that has getters implemented by default. for example, here I can't actually call the num from the instance because it's not visible.
Yeah.
But if I make it a case class, it will actually generate the getter for that automatically.
Yeah. And now if you override it there, it will use that afterwards.
Sorry?
Can you now override a getter there in some later point? So you will first use the default getter implementation and then...
Yeah, of course. But usually case classes are used for values, basically some combination of data that's immutable, just used briefly in the program. But these features actually make a really interesting case. And to demonstrate that, this is one of the pojos in one of my applications. I've used it in a couple of talks. Just a class encapsulating some data to a workout. Activities, days, durations, things like that. Really typical Java code.
Really typical boilerplate that you will need to generate with your IDE because you probably don't want to write that by hand.
Yes, exactly. But anyway, I end up about 80 lines of code.
I usually just define these first and then let the IDE implement the rest. But apparently you don't need to do that in Java.
The equivalent version in Scala looks like this.
Yeah. So that's pretty much just the declaration of the fields.
So basically it's a one-liner.
Yeah.
Which is really, really nice.
Yeah.
Changing
I wouldn't keep those on one line because it doesn't improve the readability. You can probably add some lines
that's a matter of style, I guess. But anyway, I'm sure that all of us have been at some point changing the types of your fields in a pojo. And then you have to go down.
If you
change
do that manually, then you will change the type of the field and then the type of the getter and setter and constructor. But
I can just say that's an int and that's done.
Yeah.
All right, but let's go to the Vaadin side. Actually building and creating Scala applications, you're using something called Scala Build Tool, or SBT. And we actually have a really nice template built by one of the Vaadin guys, Risto Yrjänä. That's a template to actually bootstrap a Vaadin application using that. So let me demonstrate. So I'm using a template library called Iterate, G8. And the address of the plugin or the template Risto has created is on his GitHub, so creating that. It will ask me a couple of questions regarding my project.
Can you increase the font size there in the terminal? Just put push. Yeah.
No, actually. Let's do that again. So it asked me a couple of questions regarding my project.
So this is actually not related to Scala, but this is a Iterate and that's just a project template in GitHub.
Yes, basically. And I will show you in a minute what it does. So let's give it a name for our project, a couple of questions regarding versions and stuff. Defaults are fine. And now we have a Scala and Scaladin project. So let's use SBT to actually launch the project. It will first resolve the dependencies and make sure that everything is in order. And actually, since the template includes a setup for a servlet container, I can just immediately start my application with the container colon start. So it will first compile my code and deploy it, and there it is. So let's go to localhost 8080, and here we can see that we have a really simple application that contains one label, but it took me like 30 seconds to actually make it happen. All right, but let's see what the actual code contains. So let's stop our container first and generate Eclipse bindings for it.
So Eclipse doesn't by default understand this SBT build?
Well, I think it might be...
You need to generate the Eclipse.
Yeah, basically the Eclipse files.
Yeah.
And Jitter
how about in
template
other IDEs? Do they understand SPT well?
I understand that IntelliJ at least is really good with this.
Okay.
But anyway, now that we have created those Eclipse files, we can actually let's close those and import our project. Existing project. Hello webinar. It finds our project. Let's import it, and here we go. And this is a really simple example application, and we can see that creates one UI class, gives it a title, and the content is a Vaadin vertical layout with a couple of properties. And actually we can see here that it's not a COM Vaadin UI vertical layout.
So this is the Scaladin.
Yes, Scaladin is a semi-official wrapper by us, a couple of guys in Vaadin, to create functional and Scala wrappers for Vaadin components.
Yeah. So now you can use more Scala-like API.
Yes, functional way to approach those listeners and component containers and collections and so forth. One nice thing I like is the new Valo theme. Well, it's not new anymore, but it's a default, so let's override it here. Enlarge that. Right, and let's go back to the SPT, and instead of starting our container, I will actually have it pull changes from my project and redeploy everything if something changes. So the tilde in the front means that start listening and do it again if something changes. So we can see that it's now waiting for source changes. Let's reload our application.
Valo is great. It even makes your Hello World application look better.
It's much more nicer this way, yes.
Yeah.
All right, so now it's changing our deployment as soon as we change something. So let's actually do something interesting here. Let's change this boring label into a button. One Scala convention is to actually create or use anonymous classes that are inheriting some base class on runtime. Yeah. And here we actually create a new button or a new subclass of button that overrides something in the constructor here. So here we will actually set the caption.
This kind of reminds me from the John's example because it was pretty much similar, because in Groovy you also had this thing that, was it the normal parentheses or these curly braces?
Curly braces.
So it's exactly the same thing. So now it's calling the setter for caption, and with that.
Yes, so that's actually exactly the same how it works. Yeah. And we can actually, I'm not sure if I have sources here, but we can see the Scaladin code here that we are actually creating these getters and setters that are actually just calling the underlying Vaadin component set caption here.
Yeah, but you can also use Java APIs directly, so you don't necessarily need to have this kind of wrapper. So if you have some other library, not Vaadin library, then you can still use that from Scala.
And I can just create a normal Vaadin components here if I want.
Yeah.
Anyway, here we have this new button with the caption, so let's reload our code. So here we can see the button. Let's click it, nothing happens. So let's add a click listener. And we can see that click listener for a button is actually a collection. And here we can give it any anonymous function or lambda that takes the event as a parameter. And in this case, we actually are not doing anything with the event. That's boring. So instead, we just show notification.
Yeah, you don't have to guess where the Java 8 lambdas have been inspired from.
Yeah, it's quite similar. Okay, misclick.
So I think one of the greatest features of these alternative languages is that it forces the Java language, the mother language itself, to kind of also develop its features, because otherwise everybody would be using Scala or Groovy or some alternative languages, because Java has been kind of stalled for a long time, but now it seems that there are lots of features that are being dragged in from alternative languages, not just from Scala, but also from .NET. And
even though I have to say that especially the Lambda support in Java 8, it's basically just syntactic sugar for something called single method interfaces.
Yeah, it only works if you have one method in your interface. So it's kind of a compromise, but it works in most places perfectly. So
yeah, but you can create actually methods and pass them as a parameters like that. Trivially. Anyway, one thing I wanted to show here is that the development cycle with Scala and SPT is really good. So I haven't saved this file yet. So if I go to my source code, let's actually change this. We can see that if something changes. So this is the old version yet. Let me save it. Now it will redeploy, another reload, and there it is.
Yeah. So can it reload also classes like in Java, so that you don't need to refresh the actual application?
I can use a Cherable if I want. But SPT is just scanning the source code and recompiling, redeploying.
Yeah. So your Eclipse is not connected to the JVM, which is executing.
No. I'm using Eclipse here as purely as a source code
editor. Yeah.
So basically, the same SPT setup is working with any IDE.
Yeah. With large applications, I wouldn't even want to do that. I just want to inject a new version of the class and see it live, like in Java applications.
All right, I see that we are soon running out of time.
We have already run out of time, like I expected for this webinar. So I think we could actually wrap this up. I'm not sure if we have had that many questions this time.
There were a couple of questions, I think.
Yeah, that we could actually go through. So one question was actually from David that can alternative JVM languages and Vaadin be combined painlessly in portals? I'm not sure if you have done any portal development with Groovy or Clojure.
I haven't done, but Ray Auge, who is developing For Life, right? Has written a really great blog post about writing plugins for Liferay in Groovy.
Yeah.
So I can link that in the forum as well if you're interested in developing with Groovy in Liferay.
Definitely. So technically there shouldn't be any issues because it's the same bytecode. Just put it there.
Yeah, it's a servlet, so you can just deploy it as a portlet.
Yeah, and you actually have there some kind of Scala in Liferay portlet, so somebody has been using Scala.
Yeah, I looked at this question and did a quick search, and actually there is some guy on GitHub who has created a Giterate template for creating portlets, Liferay portlets for Scala.
Yeah, so we'll definitely
and
if you actually this link also to the forum, so those who are interested about portlet development, they can check out the example. So there's a simple Hello World example that you can get started.
That's basically really trivial, and actually the amount of code you need to get that is non-existent.
Yeah. And then there was also a question about drawbacks about alternative languages. Is there something like performance, security issues? At least we discussed about performance because these are much more dynamic than static Java. So they tend to, if they use the dynamic features, it's always a bit slower, but not that much, I think. And still you can use, if you have the really big performance critical part of your application, you can always write it in raw Java, like you would do with C. You would use just assembly.
I think if there is in some cases like 10 or 20% performance difference, it's completely irrelevant for everything. If you're wanting to do something real time, you are not using Java anyway, so you are using something else.
Yeah, well, they are using lots of Java for real time stuff also, but so it's not completely true that way, but I don't think they make the slow part in most web applications, especially nowadays today, is the slow database and the slow query. So it's quite rare that, and even though if the code would be like multiple times slower in the UI level, that probably doesn't matter actually.
And if you're trying to scale your application, then actually at least Scala is really good. It comes with the Akka library. Actually, you have written a blog post about that.
Yeah.
So that's a really high quality and actor library used with
especially
with
if you have
your
lots of concurrency, then Akka is a very good library, and that's a very good example of those that have kind of written in Scala, but they can still use it in Java. So
yeah, there's a Java version available as well.
Yeah.
And Grails also has integrated Akka support,
Oh,
so you can do that as well.
Yeah.
okay, I think we are 5 minutes over our hard limit, so I think we will stop this time, and we will paste lots of links about these alternative languages to the forum, and also some of Henri, at least you have some other examples as well that you can post there. So
Sure.
So we have lots of good examples to get started with non-Java Vaadin development, and then everybody can choose the favorite language they want.
Yeah, my suggestion is to try all of them. Spend a couple of time and just play with it and see which
and
one
even
you
if
like.
you wouldn't be that seriously considering to use other languages, using these other languages will kind of force you to think in a bit different way, and then you will get some new ideas that will use in other languages as well. So you can then inspire about some reactive programming style and then implement it in Java.
Yeah, absolutely.
Yes. Okay. Thanks for watching and see you. Bye.
Thank you.